let's start the next session and let's start the. I'll first share the screen. Okay. So we are supposed to do the following three programs. The first one is quadratic equation, then the matrix addition, and then a series summation. So first, let's look at the quadratic equation part. This is the algorithm. Just take a look at this algorithm. I have already put the algorithm here. I have not really started writing the program. I just kept it bare minimum. The algorithm is the following: read ABC, check A, whether if it is not, if it is 0, then go to step 7, which is stop. Otherwise, calculate D. So let's look at these steps one by one. The first step is read ABC. This is a C programming language. So what I have done is I have included stdio.h, math.h, stdlib.h. Now, where do you write this program? You can have any text editor, or it could be an online editor. Anything can do. But I'll show it to you on how to do it on a Linux machine. Just write once you write the program, how do you compile and run it? That part I'll show you on a Linux machine. Linux machines. Okay. So I have included these three variables. First one is for reading and writing data. Second one, where I use some mathematical functions such as square root. And the third one, to exit. The exit function, if I have to stop or exit the loop, I will use this. So the first step, if you look at it, was read. Let me read A, B, C. But before I do the reading part, I need to declare those variables. What are the other variables that I need? I need these all variables also. So the first thing is read, and the reading part is done like this. Okay. Well, whether I forgot to mention, I start with int main, which can be in the same line also, but I prefer to write it on the next line. There is a personal reason, and then space, which is not necessary, and then in brackets. Inside bracket, I have put void. Void means empty. If I remove this, it's not going to make any difference. Okay. But keeping it void means that I'm explicitly telling the compiler and the computer that it is void, it is empty. Nothing is there. Then the variable declaration and read. For this purpose, I use the function scanf, and this for scanf I require this stdio.h. Okay. The format is the following. This I am going to read ABC and A. I would rather like to read all of them together instead of individual. So format is scanf. I like to have space in between, which is not necessary. I can remove the space and still work, but putting a space makes it more readable. And then since I'm reading 1, 2, 3 variables, I need to put 3 LF. This tells the compiler that you are reading a data type of data of the type double. LF means corresponds to percentage LF. This syntax corresponds to double. And putting an ampersand will make it read and store variable in that particular store the red value in that variable. After reading this, I check if a is equal to 0.0. I don't say 0 because I would like to compare them with respect to real numbers. And the syntax is like this: opening curly bracket, closing curly bracket. Whenever I have an opening bracket, I always should make sure that I have a closing curly bracket. So opening bracket, and there should be closing curly bracket. Opening bracket, closing bracket. So everywhere it should be there, so that there won't be any syntax error. If it is 0, then print as per the algorithm error, not a quadratic equation. Full stop, and I put a next line character. This is I putting in double quote, and at the end there is always a semicolon. Error, not a quadratic equation, in double quote, which is printf. This is printf. Just like scanf, printf is the output function which requires stdio.h. Error, not a quadratic equation, and then I say I would like to go to step number 7, which is exit. This is how I can do. Now, if it is not 0, then calculate d, which is equal to b square minus 4.0 star a star c. I would rather like to use the syntax like this: b star b, instead of using a power function, which is much convenient and is faster also. Here again I will check if d is less than 0.0. If d is negative, then my question, then what I do is I printf. This is the syntax again, double quote. Whenever I do a opening double quote, I put a closing double quote. This is just my this is for my convention. Then I say roots are complex. Next line. Next line. This is /n is the next line escape sequence for C programming. This is maybe true about other programming also. And then I do exit. Exit. The format is the following: exit again in bracket some number. Number has to be there. Now the fact that the root is equation is quadratic because a is not 0 and d is positive means I can find out square root of d. I do it like this: find out the square root of d, and then I say x1 is equal to minus b minus e divided by 2.0 star a. This is the formula. X2, which is equal to minus b plus e divided by 2.0 star a. What I am in the denominator part, I have put in brackets because 2 and a both should be multiplied by, the product has to be taken and that product will be in the denominator. That's the reason. Generally, I would even have spaces over here so that it looks a bit readable. Once I do this, I would like to print it. Print root 1 is equal to percentage LF x1. Printf root 2 equal to percentage LF x2. That's it. And then I return 0, which because my main program had a return type int. I said int int main. So I need to return 0, some value, some non-zero value. So that is the program, complete program. There is no problem, nothing to worry about. As I said, how do you write the program? That the way I have written, those things we can discuss when we come to when you are allowed to visit the department. There I can show it on the computers, but I don't want to show it over here. Right now, you just understand how the program is written. Once the program is written, I would like to now compile it. The program is written in the file called, I hope you can see this, called quadratic.c. This is the program. The command is quadratic. I would say put an extension, give some extension, but it should not be C. If it is C, it will be overwritten and your original program will go. So make sure it is something else, or you can even remove it. That's also okay. But you can keep an extension as X, which indicates that it is a executable file. So GCC file name .c space. So this can be have any amount of space. This is okay. So GCC, this is GNU-C compiler space the file name space -o, which means create an object or upload file of the name quadratic.x. Okay, it's not maths.h, it's math.h. Yeah. So error has gone. S was not, shouldn't have been there. Quadratic. So if I look at this command, after doing this command, if you look at this, it has created a file called quadratic.x. And if I run it, like this is how I run it on a Linux machine. It is asking me ABC. Should not be the case. What was the problem? The answers should be -3 and -2. And instead of that, if I give the value 1, -5, 6, answer will be 2 and 3. 1, 1, 3 roots are complex. 0, 3, 4. Error, not a quadratic equation. So all those things are taken care of. One. All are complex numbers. So this is how you can write a program. I don't know what was the problem somewhere. There might have been some problem, but shouldn't have been a problem anyway. Okay.
Sir,
Yes.
I want to know more about this dot x, quadratic dot x. What does dot x mean here, sir?
Okay. I'll come to that. I'll come to that just a minute. Before that, I'd like to discuss something else. Now here, by default, it prints only up to 6 decimals. I would like to have see the answer up to 8th decimal or 10th decimal. Then how do I do this? Go back to the function program. I can say, I can write like this 10.10 or maybe 15.10, something like that. So it can go over with a total of up to 15 digits, which includes the negative, the sign of the number and the dot also. So including the dot and the sign, it will print up to 15 digits, and at least 10 decimals after the dot. Let me compile and I'll explain you what is that. So I could improve upon the I could print up to 10 decimals. Now, are they really 10 decimal? How do you visualize? How do you understand this? You can split them into 3 digits. So it's easier to count. So here itself you can say these are 3 plus 3 6 and 4 10 decimals, 10 digits. So after the point there are up to 10 decimals. Now, what does this really mean? This is something which I had discussed earlier also. Maybe I can discuss this again. Okay. The programming part. I don't remember exactly which one. Yeah, yeah. So what was that that quadratic dot C? What we wrote was called the program or the source code. Whatever we wrote in that file called quadratic.c is called source code. I wrote the program and then I compile it. And while compiling, what it generally does is it creates something called object file, object code or object file. In Turbo C, it will create a file called .obj. In Windows or generally it will create a file called .obj. In Linux, it will create a file with an extension .o. So those are object files. Now those object files will have information only about the program. But what I have done is I have taken not only the program, but I have used function called scanf, printf. I have used a function called sqrt. But how does the program know, or how will the program know what does that scanf, printf does? That information is stored in the library files. So this library file information and your program, they need to be connected. And when the connection is called linking of them, linking the library files and the object files of your program, you link it and create a file called executable file. And this executable file is the actual file which you run as a on the terminal or anywhere. For example, when you do this in the Turbo C mode, if you want to just compile, I think there is a command called, I don't remember the for way to run a turbo compile in Turbo C, but to run compile and run, you have F9, something like that. The compilation and linking is done together. Yeah, compilation and linking is done by F9. When you press F9, the function key, your program gets compiled. It creates the object file, and it uses the object file of your zip program and the library files, which has printf, scanf, sqrt, or anything else that you have used. It uses information from there and creates links them together to create an executable file. And when you press Ctrl F9, you can run the program, or you can directly run the program without doing after doing this executable. You can run it separately, or you can, when you press Ctrl F9, you can do this compilation, linking, and then running. This is on Linux Windows machine. On a Linux machine, this is done like this. The GCC -C will create an object file. And then if you take the object file, which has an extension .o, you can create an executable file called hello. I have here there is no extension, but you can do the two steps together as gcc hello.c /o hello. Instead of hello, I have used hello.x. I have done the same exercise using this particular command, gcc quadratic.c -o. So this .x is the executable file which is to be executed or run on the terminal. If you are running it on the program on the website called codechef.com, if you are doing it on this codechef.com, then you don't have to worry about that. The link, the option to there's an option to run or compile, that will take care of everything. But on a Linux terminal or a Windows machine, you will have, or a desktop or computer, you have to do it yourself. You have to compile it explicitly. On a Linux machine, this is how you can do it. So I hope that answers your question.
Yes, sir.
Okay. So next, let's look at the matrix addition. Again, matrix addition part, I have written the algorithm. Let us just revise the algorithm. Read the dimensions of AB, n rows and n column, and then read the matrices. And this is the part of reading the matrices. I have put it explicitly here because here there is no limit of page. That's the reason. For 1 to n rows, j is equal to 1 to n columns, read aij, then n loops ij, then the same thing about bij, n loop ij, then C is the new matrix, and then you do the addition and save it in C matrix. So for that, you have to first declare the dimensions. Okay. N rows and n columns. These are the dimensions of A matrix, A and B matrix. Then I say, let's take integer matrices instead of float or real numbers. I call this A mat, but I would like to define the dimension. If I need to fix the dimension right in the beginning, there are ways to define it dynamically, but you can right now just think about defining it beforehand. We met in this is how you define a matrix, two-dimensional matrix. For one-dimensional matrix, there will be only one square. Only this will be there. The second bracket will be missing for one dimensional. For three-dimensional, there will be three brackets. For four-dimensional matrices, there will be four brackets, and so forth. I would also like to save the summation into a third matrix. So I will create a third matrix of the same dimension. So now I would like to read. So how do I do? First, I will need to tell the user to provide some information. So I write, please enter the dimensions of the matrices. Scanf %d %d. There are two indices, n rows and n columns. This syntax is very important. Here there are again here I have used %d because it is for integer, and there is no space in between. If I put a space, it can create problem. No space between this,
Sir,
and it is all in double quotes. Yes.
sir, in the codes that we wrote, we use space in between %d, so it did not cause any trouble to us, at least.
Where?
When we tried writing a code on CodeChef.
It can create problem. It may or may not create problem, but if it creates problem, you may not realize where the error is coming from. So it's better to avoid any space in the double quotes. Inside the double quote, avoid putting any spaces. That's it. That is what I'm saying. So after doing this, again I say you need to read the matrices. Enter matrix. Enter the elements of matrix A. For I is equal to 0, this will start from this is always my practice. I put a curly bracket on the same line of for loop. This is the for loop. I would like to, since I have to change go from 1 to n, instead of 1 to n, I go from 0 to n minus 1 because this is the C syntax. The algorithm doesn't consider C is written for a general program. That's why I can duplicate this and make it J in rows, columns, and then indent it. Scanf %d and a mat I j. Every statement at the end should have a semicolon. Should have a semicolon. If I put a semicolon here, for example, then this for loop will end over here, and this will not do any scanning reading. So in principle, you can end it anywhere else, but make sure that you end it at the appropriate places. So this is reading matrix A. So I need to do the same thing for B. So there are 7 lines which I copy pasted. You can copy paste the 7 lines the way you want. All I have to do is replace A by B, nothing else. Exactly the same. It is instead of A, it is now B. After doing this, I would like to now do a summation. C mat I j is equal to A mat I j plus. What I have done is this two loops, instead of writing it completely, I just picked up from here. Picked up the loops from here and then removed this line. In fact, I didn't even remove. I just removed what was unwanted. I needed this B mat AIJ. I just written that part and removed everything else, and then wrote the summation. Completed the statement. In fact, I am going to do the same thing again. 6 lines are there here. From here, I just saved it here, copy pasted it below. I would like to now print it. Print %d. Okay. After doing, okay, we'll wait. We'll modify this program a bit more. So after doing this, what we have done is we have declared A, declared B, declared the dimensions, read the dimensions, read A, read B, B matrix, then did the addition, and then printed the matrix. Here I can write one more statement: printf the added matrix is. I can write so that people, the user will know that this is the product, the summed matrix. So let us compile this program. Now instead of this, I have matrix addition. Again, make sure that there is a X or some other extension or no extension, but it should not be same as .c, your program. There will be several errors. Yes, there are errors. It says I is undeclared, J is undeclared. Okay, so need to declare them. I didn't purposely declare them. I would like to declare them. I copied this line, I comma J. So the two variables are declared. There are some errors, but we will see. Well, there are no syntax errors, but there are errors. Let me run. What are the dimensions? Let me take a 2 by 2 matrix. Enter the element of matrix A. 1, 2, 3, 4. 1, 2. Sorry, there is some problem. 2, 2. 1, 2, 3, 4. V matrix 1, 2, 3, 4. Does any of the matrix look like a matrix? Does this look like a matrix? Does
No,
it look
no, sir.
So it's the way we should give is 1, 2, 3, 4. No, this is just a way which is very readable for us. Enter matrix B. I'm giving the same matrix. Well, now the first two matrix, A matrix, B matrix, looks like a matrix. Fine. But the C matrix doesn't look like a matrix. Why? In fact, it looks like a number. There's no, it's very difficult to identify that. And the reason is because the way we printed the matrix C is not correct. I would like to put a space before that. I would like to put a space before the each at the end before the numbers, and then at the same time, after printing all the columns, the loop ends here. I would like to put a next line so that what it prints is one row and then goes to the next line, and then prints the next row. Let's see now. 1, 2, sorry, 2, 2, 1, 2, 3, 4, 1, 2, 3, 4. Now it looks like a proper output file. How do I this if I have to do this again and again for different values, it becomes a bit complicated. So what I do is I can create an input file. This is how I generate the input file using a VI editor. How do you use VI is not a part of this. Well, we can learn about that. How to edit file in Linux. We can learn more about that in the next semester when you actually get a Linux machine in hand. I would like to put these are the two numbers 1, 2, 3, 4. 1, 2, 3, 4. So the first two numbers are nothing but they are the values read by they are the dimensions of the matrices to be read, and then the first matrix and then the second matrix. So I can if you are running on a Linux machine or even Windows machine, you can do it like this also. This becomes much faster, much easier. And then if I find that there is something wrong, I can go back to the program, edit it, but then I don't have to re-enter the input files. The way is less than command, the executable command less than an input. The space is only for readability. This will also give me the same result. But then it does not print the output files. Remember, it does not print the output files. That printing of the output files have to be done explicitly, which I can do, which we can do it right here. We already have printed the C matrix, so those many lines we will copy. There are 8 lines which I have copied, and then over here I write down the A matrix. The A matrix is, and then here B matrix. The dimensions are also not written. So I would like to print the dimensions also. Dimensions are, and then here. So what I have done is added a line which mentions the dimensions. Then I just pick up the lines for which we wrote it for C matrix printing, and then change it to A matrix. The same thing with B matrix. We did it for A and B matrix. Now let us look at. We need to recompile. Every time you change the program, you need to recompile it. Otherwise, you will not be able to see the output. Now you can see. The dimensions are 2, 2, matrix AB, and the added matrices. This is how matrix can be programmed. The third one is summation series.
So I think there was some error in the matrix B.
Oh, that's because I printed not A, but I printed C matrix, which is initialized to 0. Sorry. Thanks. I instead of B matrix, I copied the C matrix part, but I forgot to change C to B. That's the reason it gave an error. Okay. So now let us look at the summation, series summation. Okay. So summation again. Just a minute. Series summation. Read in the number of terms. Set the value of sum ln2 equal to 0. Sign is this. So in fact, this is more or less same as your program. I can even convert them into scanf %d. This is how I can convert. I have copy pasted the whole thing for I is equal to 1, I less equal to n terms. It should be less equal to sum ln2 plus equal to, should be like this. Sin is equal to sin minus 1. Then print ln2 is equal to %ln. So each line that I have written in the algorithm was converted into the was converted into a statement.